Hello, grade 10 learners. Our topic for today is on division of polynomials using long division and synthetic division. For today's session, we are tasked to number 1, identify polynomials from a set of algebraic expressions. Number 2, determine the degree, leading coefficient, and number of terms of a given polynomial. Number 3, divide polynomials by divisor of the form x minus c using the long method. And number 4, use synthetic division to find the quotient and remainder when a polynomial is divided by the binomial x minus c. Now let's start. Let us begin by defining what is a polynomial expression. A polynomial in variable x is an expression of the form a sub n times x raised to n plus a sub n minus 1 times x raised to n minus 1 plus a sub n minus 2 times x raised to n minus 2 plus up to a sub 1 times x plus a sub 0, where a sub n minus 1 up to a sub 1, a sub 0 are constants. Here, a sub n cannot be equal to 0 and n is a non-negative integer. Note that the constants a sub n minus 1, up to a sub 1, a sub 0 are the coefficients of the variable x. The variables in a polynomial must have exponents that are positive integers or 0. The degree of the polynomial n is the highest exponent of the variable in the given polynomial. Let us have this activity. Identify which of the following algebraic expressions are polynomials. For number 1, we have 6x squared plus 2x minus 2. Is this a polynomial or not? So this one is a polynomial. It is a polynomial because the exponents of the variable x are not negative. So for number 2, we have the square root of 3x plus 3x plus 3. Is this a polynomial or not? So this is not a polynomial simply because the term square root of 3x can be written as the quantity of 3x raised to 1/2. So for number 3, we have x to the 7th power plus 3x cubed plus 2 over x. Is this a polynomial or not? So for number 3, this is not a polynomial because of the term 2 over x that can be written as 2 times x raised to negative 1. So for number 4, we have 4x cubed minus 3x squared plus x raised to negative 2. Obviously, this is not a polynomial. This is not a polynomial because the exponents of the variable x are negative. So for number 5, we have square root of 2 times x plus 4. Is this a polynomial or not? So this one is a polynomial. This is a polynomial because the radical sign is not for the variable x, but for the constant 2. Let us have another activity. State the number of terms, the degree, and the leading coefficient of each polynomial. So remember that the number of terms are counted by the number of monomials that make up the polynomial, while the degree is the highest exponent of the variable in the polynomial, while the leading coefficient is identified by the coefficient of the leading term. Now, let's have number 1, 2x cubed plus 7x plus 5. Let us identify the number of terms, the degree, and the leading coefficient. So we have the number of terms. So we have here 1, 2, 3. So we have 3 terms. The degree is 3 because 3 here is the highest exponent of the given polynomial. So the degree is 3. And the leading coefficient is the coefficient of the leading term, which is positive 2. Now for number 2, we have 12x to the 7th power plus 6x to the 5th plus 2. So the number of terms, again, we have to count it. 1, 2, 3. So we have 3 number of terms. The degree is 7. Since 7 is the highest exponent of the given polynomial. And of course, we have 12 as the leading coefficient. For number 3, we have 3x plus 2. Number of terms is 2. The degree is 1. And the leading coefficient is 3. Number 4, we have 3. For the number of terms, we have 1 term. The degree is 0. So, a polynomial with a degree 0 is called a constant. And of course, the leading coefficient here is positive 3. For number 5, we have 5x squared plus 7x plus 5. How many terms do we have? So, we have 3 terms. The degree here is 2 and the leading coefficient is 5. Now, moving on with our discussion, the division of polynomials wherein the divisor is of the form x minus c, where c is a constant. The algorithm or process is just the same as the long method of division in arithmetic. This can be expressed as dividend equals divisor times the quotient plus the remainder. So in symbol, we have P of x for the dividend, D of x for the divisor, Q of x for the quotient, and R of x for the remainder. However, when the remainder is expressed as fractional part of the divisor, then the general format becomes dividend over divisor equals quotient plus the remainder over the divisor. Now, let us consider this example. We will use the conventional long division to divide 5x plus x squared plus 3 by x plus 2. So, for the first step, we are going to use the format of long division from arithmetic and arrange both the dividend and the divisor in descending powers of the variable. So, on this case, our dividend is 5x plus x squared plus 3. So, we are going to arrange this in descending powers of the variable x. So, we will obtain x squared plus 5x plus 3. And then, we're going to divide that by x plus 2. So, for the next step is find the first term of the quotient by dividing the first term of the dividend by the first term of the divisor. So, in this case, we are going to divide x squared divided by x. So, we will obtain x. And then, multiply each term in the divisor by x. So, we have here x times x, which is x squared, and x times 2, which is 2x. So, we're going to place here the product under the x squared plus 5x. And now, we are going to subtract them. So, x squared minus x squared is 0. And then 5x minus 2x. So, the difference is positive 3x. And then we're going to bring down positive 3. Again, we are going to divide 3x by x. 3x divided by x, and the answer is positive 3. So here, the 3 again, we are going to multiply 3 to each term of the divisor. So we have 3 times x and 3 times 2. And that will give us 3x plus 6. So we need to subtract this. So we have 3x minus 3x is 0. So we have here 3 minus 6. So the answer is negative 3. So therefore, we have here the quotient, which is x plus 3, and the remainder, which is negative 3. So here the quotient is x plus 3 and the remainder is 3. And also the final answer can be written as x plus 3 plus negative 3 over x plus 2. We have a shorter way for dividing a polynomial by binomial x minus c, and that is by using synthetic division. So let us consider the same example that we did using the long method. So in here, we have to follow this step. So we need to write the coefficients of the variables of the dividend in order of descending powers. So on this case, if we are going to arrange the coefficient of the dividend, we have 1. Because of the x squared, the coefficient of x squared is 1. Next is the coefficient of 5x, which is 5. And of course, the constant term is 3. So remember that we have to put 0 in place of the missing coefficients. But since we don't have missing coefficients here, or missing terms, so we have 1, 5, 3 as the coefficients of the dividend. And then, we're going to write the constant c of the divisor in a semi-box on the left side of the first row. So we are going to place here a small box, and then we're going to place here negative 2. We have to place negative 2 because of the additive inverse of the x minus c. So we are obtaining x minus c, so it means we're going to get the additive inverse of positive 2, which is negative 2. So for the next step, we're going to draw here a line. And we're going to bring down the first coefficient in the third row. So the first coefficient is 1. And then we are going to multiply 1 by negative 2. And the answer will be negative 2. And we are going to place it under 5, which is of the second row. And then we're going to add 5 plus negative 2. And that is positive 3. Again, we are going to multiply 3 by negative 2. And the answer is negative 6 will be placed under positive 3. And we have here 3 plus negative 6. And that is negative 3. So you have to take note here that the numbers in row 3 here are the coefficients of the variables of the quotient. And the last coefficient here is what we call the remainder. So for us to write the quotient, we have to take note that the degree of the quotient is 1 less than the degree of our dividend. So since the dividend is x squared, it means that the quotient is only x. So it means that the quotient can be written as x plus 3. While, of course, the remainder is the last coefficient here. So the remainder is negative 3. So remember that we have here the same answer using the long division. So let us deal with this example. Use synthetic division to divide 3x cubed plus 4x squared plus 8 by x plus 2. So for the first step, we need to write the coefficients of the variables of the dividend in order of descending powers. And remember to put 0 in place of the missing coefficients of the variable. So on this case, the coefficients of the dividend, we have 3, 4, 0, 8. So let us explain why did we arrive with 3. Because this is the coefficient for the x cubed, which is the highest exponent. And we have 4 here for the coefficient of x squared. And since we don't have the coefficient for the variable x or the linear term, we have to place 0 here and 8 for the constant term. And of course, we need to write here a semi-box. And we're going to place there the constant c. So we get the additive inverse of positive 2, and that is negative 2. And then we're going to draw a line. The first step is to bring down the first coefficient in the third row, and that is 3. 3 times negative 2, we have to multiply them. We have negative 6. And then we add 4 plus negative 6, and the answer is negative 2. We then again multiply. Negative 2 times negative 2 is positive 4. And then we add 0 plus 4 is 4. We multiply again. 4 times negative 2. And the answer is negative 8. And then we need to add 8 plus negative 8. And that is 0. And now for us to write the quotient would be, remember that the degree of the quotient is determined by subtracting 1 from the degree of the dividend. So since the degree of the dividend is cubed, it means that the degree of the quotient is squared. So we have here 3x squared minus 2x plus 4, and the last coefficient will be the remainder, and the remainder is 0. Now let's try to do this. We have here the long division method that is done already for you. And let us try to identify the following. What is the remainder? What is the divisor? And what is the quotient? For the next problem, using synthetic division to divide 3y cubed minus 7y squared minus 20 by y minus 3, which of the following is the correct first row of the algorithm? And for the next problem, we have here the coefficients for the synthetic division. So let us try to answer this one. Which polynomial is the dividend? Is it A, B, C, or D? And for the next question, which polynomial is the quotient? Is it choice A, B, C, or D? So that's all for today, guys. Until our next session, thank you and enjoy learning.